Hello, good day, and welcome to my channel where we make structural engineering design simple and easy. My name is Olodu Konyede, and I'm your host. I want to say very big thank you to everyone who has subscribed to this channel, and those who are yet to subscribe, please hit that subscribe button. Today we'll be talking about Raft foundation, how to determine the slab thickness of the raft and how to design the raft. So let's dive right straight in. Um, Please check our previous video on how to design the superstructure that has been done. We'll be focusing on just the foundation. So after you've done all the superstructure analysis and design, we come to story zero. Double click on story zero. So once you click on story zero, it comes to this point. So what we need to do for a Raft foundation is we'll be using um, our beam. We are designing for Raft beam and slab um, foundation. So we do the beam. The beam, we are saying the beam, let's do, it all depends on your soil test and where you can get a famous soil. But from the soil test we did on this structure, we are getting it at 1.2 to 1.5 depth of the soil. So, but we're using 1.5 and 300. So that's what we do. So we keep. So if you look, we've done this or this. So what we'll do next is to um, put slab on it. So if you click on your slab icon, we'll use, I want to show something about how to determine the thickness of the raft. So we use the lowest raft slab thickness for now, 150. We'll come here, all these things are already there. If we come to this level now, this relative level, at zero it means it's starting from ground, but no, we have we'll say 1200. That's our relative height that we'll take. So if we say okay, yeah, so let's put our, so if you see the 3D section, so we are having it the way we want. So after we finish there, let's put our wall load. Let's put wall load on it. Edit wall load. We edit wall load on it. Just give it time. Typically 3.47. 3.47. We do height 2.1, 2.7. Please check our previous video. I've already explained all these things. So we've already explained all these things. Please check and we'll say okay. So what we do, we copy this, copy, paste. So with this, we've pasted it. The next thing we need to do is we'll come to strip. This is analytical, but change it to FE strip. Hold down your control key and draw your line straight. So with this now, come to analysis. You come to FE Raft foundation analysis. Let's run the analysis. So if you look here now, will not if you come here, whatever is your soil test, your soil bearing capacity, let's say we are saying 150, depending from the soil, and I put it here, then come here, run. You can check all this. You run Raft foundation mesh analysis. Click here so that it runs. So once it start running, give it time to complete the running. So you come here, click generate model. So it has finished analyzing. Close it. So once you close it, it will take some time to generate. If you look here now, it's performing FE slab analysis. So give it some time and it will run the analysis for you. So it has finished analysis. It has come to this point. So whatever is our soil bearing capacity, this we'll put it here. So come to analyze post processing. So give it time. So it has analyzed it. What you need to do is, if you click on this draw slab strip, it brings your drawing, your projects, your model on where you can see properly. We click on standard contour for displacement. This is it. But what we'll do first is to check for our service load, the soil test, and the soil bearing capacity for our service load. Then if you check properly, give me some time. Let me do so that you see what I'm seeing here. But if you check, I don't know whether you can see it properly. I'm trying to see, but if you click on soil pressure at the list, I don't know why it's not showing. It was supposed to show. Okay, let me see if I can reduce it so that you see. It's not opening. I don't know why, but let's just see. Okay, let's proceed. Okay, good. This is what I wanted to show you. So if you look here, you see soil pressure. Click on soil pressure. So if you look carefully here, you see the soil pressure. Our soil pressure, if you look carefully, the pressure is around the edges. The maximum pressures are around the edges. So this is how you check if your design is okay. But there's a trick I want to show you. If you come to general, if you see plan here being highlighted, unhighlight it or click so that it's not highlighted, then come back to results. So if you come back to results, hold on. If you come back to results, let's zoom to see. Let's see what we can see. Over this, if you put your cursor over here, look here carefully, it will tell you 152.328 is less than 210, which is okay. And how did they get this 210? Prota does something. Prota does whatever um, soil bearing capacity you give to it, it multiplies it by 1.4. So if it multiplies by 1.4, this is what it use as your soil bearing pressure, that whatever the the building is producing, the pressure the building is producing, it equates it to 1.4 times the bearing capacity. So if it's less than 1.4 the bearing capacity, then it's okay. So what do? We take our cursor, we move it around, and you see it's okay. But if you come to this part, and it's now showing you warning because is now higher, which there's a way we can solve this by just putting apron around it. But I think there's another video I did about how to take care of that. But typically, this is how you go about it. By moving your cursor, you are looking at this that is okay. So majorly, this thing I would say is okay. It passed through. This thing passed through. Just this little one that we can take care of by using apron. So that's the way to determine your if your raft passes, if the weight of your raft or the pressure exerted by your raft is less than the soil bearing capacity. This is how you do it. But if you want to know if the slab thickness is okay, you come to this direction. If it's okay, normally if you do, you see these two area, design moments and required steel area. If you click on this, it transfers whatever it is to the other. So if you click on required steel, it shows you that there's an error. The thickness, it shows you the insufficient slab, that the 150 you use is not okay. This is very important. So with this, you go back, increase your, if you go back, you increase your thickness of the slab, run the same process we've done, come back, and you start clicking on the moment. But once you click on the required reinforcement, it will show you that the slab is not thick enough. So you have to go back, increase it until this passes. So with this, you can determine the slab thickness you want to do. Then if you want to check for the reinforcement, of this, if we come to um, um, this thing, let's say edit, come back to standard, sufficient. Okay, come back to, if we, at first we understand that if you come to user defined contour, you click on edit contour. If you click on edit contour, it shows you the lowest steel required, area of steel required, and the maximum area of steel required. So if you see this now, we can, if you change this now, let's say we say 150, the contour value is 753, which is around here, but we still need more reinforcement. So this is what we do. So for you to change this, because now from initially when we are doing let me just show you what to do now. With this, what we plan to do is to increase the diameter and the spacing so that the reinforcement area is greater than the maximum area. So that is how you can design. So let's go back, let's close here, let's close. No, we are not transferring. Close here. So what I was saying is, if you come to analysis, building analysis, come to building analysis, come to edit material. Already on our foundation floor, we said I think we used this. I'm coming foundation floor, so we need to increase it. So on our foundation floor, let's increase. Let's do 13. No, let's do 13. Let's do diameter 12, diameter 16, and let's say 20. For a slab, we can just do, for slab we did 12 before, let's do 16, let's do 20, and see. Once you say okay, you can close. Then same, and already we said something before, the slab is not thick enough. So let's say we click, hold down the shift key, not this, let's say we hold down the shift key, click here. For the slab, right click, property. So with this, we can, if we click here now, edit, we can change everywhere to, let's say we do 300. Let's do it 300. So it automatically increases the thickness. It automatically increases the thickness. We say okay, we can close. So with this now, we can run our, go back to this, run our analysis and see what, say yes. We do same process, click here, same process. Let's give it time to run. It has run. We'll close. Performing FE slab analysis. So same process, just give it it moves to the next one. So same process, click post, analyze post processing. Same thing we do. Click on this. Once you come back general, it's plan view. Uncheck it so that it's not checked. So come back to results. Click on this. Come to service load as 1G, 1.0 G plus 1.0 Q. So with this now, same process that we did before. Same process. Come to soil pressure. Click on soil pressure. So same, you just keep moving. If you keep moving, it will keep showing you here. If you look here, this is where I want you to look. Pay attention here. It keeps, if you keep moving, you keep moving, it shows you 45. It has reduced it. So this is what you do. Just go through. Then to know if your slab pass, let's click on this. Let's do the next one. Then we'll move to required steel. So if you look carefully, the number of slab that has reduced, the number that failed has reduced to only 55 F58. So if you look at that F58, with that you can solve down. So there are two ways to solve that, but let's just leave that one for now. Let's just get the reinforcement. So if we do that, let's say edit. So you see we've achieved more. We can now say 200. I would say 150. So this is how we typically edit and do the maximum. So this is how you check for your reinforcement, the slab thickness. But normally what I do if I want to do Raft, if I check, because normally if you look the slab width, okay, let's close here. If you look at the slab width and length, you find that it's 5 meter by 5 meter, which is quite big. So what I do normally is to break the span. If you break the span, it will reduce all this challenge you are getting. So that's the second way you can do that. Another way is to create apron. So I think I'll stop here. If you still have any question, if you still have any, we say no for now. We are not transferring it. And if you look, oh yeah, let's see 5, 8. Let's see if we get any 5, 8. So this is it. Either you, okay, it's F58. Okay, so the one that was having issue before was this. So if we put we break this spans, if we break the span, it will work. So just try that. You break the span by adding another beam across here, another beam across, another beam across. So that would solve the problem. So I hope we learned one or two things here. And if you still have any question, please feel free to send your question in our comment section, and we'll be glad to respond to you. And if you are yet to subscribe, please hit that subscribe button. Until I come again next time, remain blessed. Thanks.